First of all, let me tell one more thing. Daily basis, I'll be recording the session and I'm going to hand over the same session at the end of the day to someone of the Tetra team, some admin team of Tetra. Okay. And he or she used to upload the recording into some YouTube link and you can check the videos from the YouTube link. Okay. So this is the procedure of uploading the data. So maybe you were skipping the classes for any day, so you can check the recordings from the links. Okay. So after SQL, we are having business intelligence. Means how the data we are preparing the data. Means data engineers are preparing the data and how that can be helping the business to be grow their business. The business team. Okay, that we'll be learning over here. What are the procedures? What are the things we need to do for the for the data to be understandable by the business. Okay, so there are 2 or 3 days class for business intelligence. It's very, very important. So this is one of the main focus area of why the data engineers are required in the industry. The second focus area after SQL, the big classes, maybe you can see this is more than 1 week classes we'll be going to cover for SQL. Maybe 7 to 8 days. Sometimes, while solving the exercise, it can make much more time than the scheduled week. 8 to 9 days can be covered by SQL. Similarly for Python as well. Python will be starting for 1 or 2 days for very basics. After we are learning basics, we'll be using Python as a data handling tool. Okay. But Python is, it's a big language. We will not be going to learn all the aspects of Python. We'll be learning the basic stuffs first, very basic thing. Then we'll be switching Python to use as a database engineering tool. So there we will be using data. We will be creating data frames by using some external module called pandas. I hope you are aware of, maybe you are hearing this thing pandas nowadays because this is very, very popular Python libraries which can handle data very well. Okay. Some other aspects we'll be learning over here on top of Python. So Python will also take more than 1 week to be covered. Okay, maybe 7 to 8 days. So the main focus area should be those things: SQL, business intelligence, Python. After we are learning this thing, we'll be covering few days on top of cloud computing. It's nowadays it's also getting integrated with the data engineers as well. The cloud concept. So I'll be giving brief cloud concept. It's not totally very detailed, unlike SQL and Python. Some brief introduction on top of this, how the things are handled, how cloud is important for our data engineers. Okay. Then there should be few days classes for big data, especially focusing on Spark. Spark is one of the big data tool. Big data is nothing but large volume of data. How to handle large volume of data that can be solved by big data tool. Spark is one of the big data tool. Okay. Then we'll be having 1 day session for Git. Git is nothing but a code-based repository. So when you will be writing codes, you can store your codes in Git. Okay. So it's a version control as well as store repository. So suppose you want to store all of your codes, how you are practicing it, how you are evolving. So you can store it and you can compare it there. Okay. Maybe when I'll be giving you projects, you can write the projects over here and submit me, share me your Git links so that I can check the code from your Git. We'll be also having session for Power BI. Power BI is a visualization tool. So 2 or 3 days will be reserved for Power BI for a quick learning as well as hands-on part. Okay. No, Rosni will not be covering Tableau over here. Instead of Tableau, Tableau is one of the visualization tool. That's why we'll be introducing Power BI. Power BI is also a visualization tool. Over there, we'll be creating charts and graphs. So we'll be covering Power BI as a visualization tool, not Tableau. Okay. So any doubt from your side? Azure training, yes. So I'm just going to cover Azure or introduce Azure in this. Maybe for AWS, I'll be showing 1 or 2 days. For Azure Basics, I'll be also showing this thing, how the console looks like, how the components are. So the very basics part, how Azure console looks like and all, how we can launch a data bricks, I mean environment, those kind of thing we can cover over here. This is the plan. So maybe 1 or 2 session should be covered up during the cloud computing. Okay. Any other questions from anyone? I found some new persons just joined. Okay, what you just joined, correct? Hi, Varti.
Hello?
Yeah. You just joined the class,
Yeah,
correct?
yes, I just joined.
Okay. Do you already have the data experience or you are?
I do
You
have
already have
testing experience,
testing
not data.
experience on top of data, correct?
Ye- I don't have any data experience testing QA mobile testing.
Okay, fine. So
Yeah.
we just cover up the syllabus part. So this should be going to be our syllabus for coming
Mm.
1 month, 2 weeks, just like this. You can just check. Everyone can see this thing. If there is any stuck point or any doubt, you can tell me. This should be the syllabus we are going to cover over here. Okay, so uh, during the classes, maybe the technical classes for SQL and Python, I'll be going to, put you some exercises to be completed. So the exercises should be very simple. Please try to solve the exercise by your own, and maybe you can upload the things in Git, or maybe you can share me the codes separately by my mail ID. But please solve it. As per the previous experiences of previous classes, very few people are going to solve this thing. But I'm just advising, if you are just completing this or you are practicing this, then you will be much more efficient to solve this kind of SQL. But if there is any stuck point or anything while solving, or, while learning the thing, please stop me and ask me question. There will be no issue. Okay. But please try to solve those things by your own. Okay. Any question so far from anyone? Anything you want to ask? Nothing? Okay. Let me start today's session. Today it's totally basic things. On top of data, we're just going to cover over here. I'm presenting. It's already recorded. Let me present the screen. So each day I'm going to share a PPT. I'm not going to share actually. I'm going to present over here a PPT. Based on the PPT, if there is any hands-on, I'll be going to the hands-on tool and I'll be showing the thing. As of now, the basic things we do not have any hands-on. From starting from SQL, there are lots of hands-on part. So while doing the hands-on, before starting the hands-on, I'll be giving you the instruction how to install a particular tool at your side as well. So please install those kind of tool at your system. If it is already there, no issue. If it's not there, please install. And while doing the thing, please try at your side as well. Okay. Or maybe after the courses, you can take a few notes of top of this thing. As soon as the class is over, you can just go ahead with the hands-on part. Okay. If there is any stuck point while doing the thing, you are getting error while running the codes, the very next day you can show me what are the things why you are getting the issues and all. Okay. Daily basis, there should be 1 hour classes. We'll be discussing first. We'll be trying to cover within 1 hour. But if there is any stuck point, you can tell me questions after that or at the middle as well. You can ask me questions. Okay, so this should be the next 1 month or 2 weeks structure, and we'll be going to cover in this way. If there is anything you can tell me. Okay, let's start our first day's class. It's very much totally introductory part. How the data looks like, what are the different kind of data we can handle and all. Okay, so what is data? We know the data, it's a collection of information describing quantity, quality, fact, statistics. Okay, so why? Nowadays we are hearing about data, data engineering. On top of data, data sciences are there, machine learnings are there. So lots of things are coming. As a emerging things on top of data, because data will be helping us to see. Our forecasting our businesses as well. This is very much important. So we have one slide just like what are the different data engineers enterprise. Suppose we are going to join a data engineer. When you are going to join a data engineer, you will be giving interviews to the clients. Okay, clients or maybe any consultancy companies. When consultancy companies will be hiring you, your client can be a banking sector, a commercial sector, insurance sector, medical sector, pharmaceutical sector, lots of other sector. Because each of the sector you can see, just like banking sector, the banking client, the banking owner, they are having lots of clients actually. And the clients are filling up their data, storing their data. Maybe they're lending some money, they're depositing some money, all kind of informations. They wants data engineers to be analyzed. So the data analytics team or data engineer team, they are analyzing the data. They can help the owner how to improvise their business based on their fault. Okay. So to check the data, they are preparing such a good scenario. They are getting some hidden trend of the data. How the next 5 years, how the next quarter will be giving them their growth and all these kind of things we can easily see by the data analytics team, by the suitable charts and graphs. Okay, so based on the transactional data, the data engineers will be handling the data and give them a good model. They will be shaping them with a nice manner so that uh, the particular business owner, they can take decisions that their business is not going well. They need to take these decisions. Okay, so this is the overall thing, the purpose of data engineers. It's not only banking sector, it's commercial sector, insurance sector, okay, medical sector, pharmaceutical sector. In each of the cases, suppose I'm owning a shopping mall. This kind of exercise, example I already gave to everyone the previous session. I'm owning a shopping mall. In a particular shopping mall, maybe I'm seeing that my growth is, last 1 or 2 quarters, it's not good for few of the branches of my mall. The other branches, it's going good. Few of the branches, it's not going good. So I need to fix my issue. How I can fix it? So I'm hiring some data engineers. What they're doing? They're processing the source data. What kind of source data they're processing now? So maybe customers are purchasing something. They are having billing information. We all are having the billing information in our databases. Even we are having the satisfactory index from the customers as well. So you can see maybe which particular product they are purchasing and what is their satisfactory indexes. And the data engineers can compare those things. They can prepare graphs and charts. Based on that, we can assume which particular products are liked by customers, which are not. Which are the frequently purchased product, which are not. Okay, suppose particular products, those products are not getting sold for 1 or 2 years. Okay, but a big industry, it's not very easy to check it. But if we have the data engineers, they can shape the data in a proper way. They can create such a chart that will help the unsold product for last 1 or 2 years. and those are getting expired by the expiry date, but it's not going to be sold. So those are the losses. But this kind of data can help the business owner. Business owner is checking that this particular product is not getting sold for particular branches. They will be reducing their plans. I mean, that particular products marketing over there, or they will be not selling their product for their particular branches. Okay. And the best selling product which are getting sold very frequently, they're having huge stock. They're going to grow their stock on those particular products. So this can be a strategy. Maybe the selling is very less. Maybe for the particular customers, they used to buy lots of products earlier. They are not buying the product anymore. So you need to give particular offer to that particular customers. Maybe if I'm just a business owner, I can think in that way. It totally varies on the business owner how they will be handling, especially who are doing the MBAs and all. They are assisting the business owners with that kind of scenario. But as per the data engineers roles, they are preparing the source data. Source data mean during the maybe a customers, what kind of data we are collecting from the customers. They're analyzing all this kind of data, not only for the customers. To run a shopping mall, we have lots of employees as well. We need to pay salaries to the employees. So there are different kind of other informations as well. The data engineers will collect those information. They are cleaning the data, the wrong data. They're transforming the data in proper way. They're storing the data in a proper manner in some data warehouses. And then some data analytics team, they're creating suitable charts and graphs. By checking those charts and graphs, the business owner, they can take the strategy. They can take the new decisions. So this is the purpose of data engineer actually. Starting from the scratch, they will be taking all those data, transactional data, and presenting with the beautiful charts and graphs in front of users so that they can take their decisions. Okay. So in each of the sectors, in each of the enterprises, data engineers are required nowadays because all of them, they want a growth to their own industries. Okay. Any stuck point, I mean, did you able to understand? I found some more new resources just joined, so I'll be requesting to join in time. So we just cover more than half time of today's session. So please join in time. Otherwise, you will be missing some portion of the classes. You again need to check the recordings. Okay. Now, from the next slide, when we are storing the data, we can store the data either in relational database or non-relational database. Let me maximize the screen. So let's first start with the relational database. So the first picture, you can see it's a relational database. We are storing a name with the particular person's email IDs. Okay. So this is one kind of data representation. At the below again, you can see the same data is getting represented over here with a different manner. Okay. So the first one is called relational database, where we are following a table-based format. Okay. Why it's called table-based? Because it should be having columns. Columns just like name, email. When our columns are fixed, maybe other attributes are there. Maybe the particular person's age, gender. Maybe other columns are there. Total 4 columns are there. For relational database, we need to fix our column number first. And what kind of column should be there? We need to fix it first. When the column numbers are fixed, our table structures are fixed. Now we are going to insert the data. Means we are going to fill up the rows one by one. This is how relational database works. So let me repeat once more time. It's following the table-based architecture, having fixed number of columns. When the column numbers are fixed and everything is fixed, then we are going to insert the records. Records are nothing but the rows. Okay, rows of the table. Excuse me. One by one. And this way it should looks like. It's called a relational database. Or the entire thing is called relational database management system, where we are having multiple tables as well. Okay. The below section, it's a non-relational database. We are not storing the data in columnar format. Rather, we are storing it with a key values pair. Name, Ram, email, ram@gmail.com. This kind of information are there. Suppose I'm going to introduce a new attribute. Suppose age. So I do not have to create this kind of columns earlier. Then I need to insert it. Rather, for which data I am having the particular attributes, I can quickly put a comma and add it over here. For which records it's not there, I do not have to add it. So there are specific, functions of each of the database. Some of the cases will be using relational database. Some of the cases will be using non-relational database. This is totally as per our own wish. Okay. So based on the usefulness of each of the database, we are going to use it. But coming from the next session for the data analytics person, as we are the data engineer, the main thing should be going at the analysis part. So if the data is getting stored in relational database management system in this way, the analysis is very, very good for us. So that is why for analytics purpose or analysis purpose, we will be following relational database management system. Suppose we need to retrieve the data from the database very quick. Okay. So suppose the non-relational database is very, very fast than relational database management system. So we need to retrieve the information. Suppose I'm designing a chatbot or just like this chatbot. They need to give the answers to the user. So at the back end, when we are storing the question versus answer, this kind of pattern, we need to follow a key value in this kind of data sources should be at the back end, so that when I'm asking the question to the bot, they'll be try to retrieve the answer as soon as possible, because there is very less lagging time. If the lagging time is very high, suppose I'm going to ask some question at the back end, the chatbot is going to query from the relational database. If the table is very huge, they need to retrieve the data. Maybe 1 minute time, they're taking 1 minute time to retrieve the data. So their performance should be very poor. Okay, because if a bot is replying you within 1 minute, their time is 1 minute, then will be, especially the particular who are using the bot, they'll be very much dissatisfied. They will not be asking any question to the bot. They will be directly going to the chat agent. So that is why, suppose for this kind of scenario, we need to, get some informations from anyone with very quick manner. Then at the back end, we need to store the data in this format, in non-relational database format. Okay. Let me go to the next slide. Yeah, based on the relational database management system, you can see those things. Relational database or relational database management system stores information in table that I already told. These tables have shared information between them, causing a relationship between other tables. Okay, so in relational database management system, we should be storing multiple tables in a single database, and each of the table should be keeping relationship with another table. How this is possible actually? How one table should be having relation with other table? That should be, starting with the key concept, primary key and the foreign key concept, which I'll be showing. Yeah, today we have one slide for showing this thing. Yes, for this one. Suppose in a relational database management system or RDBMS systems, I stored these 4 tables. The first table is storing the customer related information. Second table is storing order related information. Third table is storing address, all the customers address related information. And fourth table is storing the product related information, which particular product they have purchased from a particular outlet. Okay, these 4 tables are getting stored over here. Now, suppose you want to see a particular customer's address. Okay, but if there is no such relation between customer table and address table, you will not get this information. In the customer table, we are having customer ID, customer date of birth, that is fine. The particular order ID, the particular customers has placed, that is also there. Address ID is there. Means a particular ID has been given to the particular address, that is fine. But the detailed address, it's not been getting stored in customer table. It's getting stored in address table. Okay, with along with the address ID as the index of the address. So if we have relationship between customer and address table, we are already having the relationship is established by the common column called address ID. Address ID is present over here. Address ID is present over here as well. So we have the common column which will be setting the relationship between these 2 tables. By comparing the same address ID, we can confirm the particular customer's location, the particular customer's PIN code. Okay. Similarly, over here, we do not have the particular information of the particular customer is purchasing which particular product in a particular order ID. Okay, we only having order ID. But you can see we have a good relation over here. The customer table and order table, we are having common column called order ID. Okay. In order table, we are having product ID. And in the product table, we are having also product ID. Okay. By analyzing this common column, we can also set relationship between order and product table. And again, we can set up relationship with customer table. So we can easily identify a particular customer ID has purchased which particular product and what particular ratings he or she might have given. So we need to set relationship between these 3 tables to get all the informations all together. Okay. Now the concept is, you can see just like for the customer table and order table, there are the common column called order ID over here and order ID over here as well. So first of all, just see in this order table, order ID should be unique in nature. So there should not be any repetitive order ID. Similarly over here in product table, product ID should be unique over here. Means I am giving one particular product ID to a particular product. Okay. But in this particular table, product ID is not unique. Maybe in a particular order ID, a particular product has been purchased. Maybe another person purchased the same product. So another order ID should be having the same product ID. Let me just tell me again. In the order table, product ID can be repetitive in nature. Okay. Maybe based on each of the order, the product ID can be repeated. But in the product table, product ID should be always unique. Over here, we are only storing product related information. Each of the products should be having one product ID. Okay. Now, this uniqueness of these columns in the product table, it's called primary key of this table. Okay, in a relational database management system, we are having tables. Each of the table should be having one unique column. Suppose I'm just storing one particular class 9's, all the students information. Class 9 section A. Okay. So there we are storing student's name, student address, student roll number. So student roll number should be always unique. There may be same name for a particular student, maybe same location in the particular table, but the roll number should be always unique. We are putting same roll number, different roll number to the different students. Similarly, product ID should be different for each of the product. Okay. So product ID is performing the primary keys operation for this product table. This is the concept of primary key, very important. I'll be telling the same thing again in tomorrow's session, but try to clear your concept on top of primary key. What is primary key in a table? The particular column which should be unique in nature, or we can also say each of the data, maybe roll number 2 is identifying a particular student's information. Roll number 3 for class 9, it's identifying a particular student's information. Kind of it's a row identifier. Okay, product ID, that particular data should be row identifier for the entire data, entire row. Okay, oh sorry, I'm just going to the next slide. Okay, now the similar product ID in this table, it's called the foreign key. Okay, in the order table, order ID should be primary key because order ID should be unique in nature. And product ID should be the foreign key. Foreign key, why it's foreign key? Because it's primary key in another table and we just introduce the foreign key just to set up the relationship between these two tables. Okay, so please clear your concept what is primary key and what is foreign key, and with having this primary key and foreign key we are just creating the entire relationship or relational database management system. We have our primary key and foreign key, that is why we can able to set relationship between two tables, and the relational database management systems are getting created in this way. The same similar kind of thing I just explained over here in my previous slide actually. So let me repeat the thing once more time. Relational data. Relational database or relational database management system stores information in tables. So in a particular database, there can be lots of tables. Okay. Each of the these tables have shared information between them, causing a relationship to form between tables. This is where a relational database gets in name form. That is, that is why we are giving them the name of relational database management system. A table uses column to define the information being stored and rows are actual data. Okay, just I mentioned we need to first form the columns. When the columns numbers are fixed, we are able to insert the rows. Rows are nothing but the actual data. Each table will have a column that must have unique values. That is called the primary key of that particular table only. And this column can then be used in other tables. Okay, the primary key, that particular column can be used in other tables as well if relationships are to be defined between them. In the other table, if we want to set up relationship between them, when one table's primary key is used in another table, this column in the second table is known as the foreign key. Okay, the same thing, just like address ID is the primary key in the address table, but the same address ID when I'm using over here, just for setting relationship between these two tables, this address ID is the foreign key of customer table. Okay. So the concept is clear. What is primary key? What is foreign key in the tables from everyone? If there is any stuck point from anyone, It's not understandable. Please tell me. It's fine for everyone. Please respond. You can just put on chat. If it's clear for you, it's not.
Yes, it's clear.
It's clear? Okay.
Hey, Soptik, I have some doubt.
Yeah, tell me, please.
You said like primary key is when we go through, if we go through customer ID, we can enter primary key over there, and like to combine the customer and order table, we can use foreign key, right?
No. The concept is just like this. One table. Okay, let me just go through chat. It's clear. Okay, fine. Okay. So by verb, for order table, suppose let's focus on only order table. Okay. While entering each of the records one by one, so we are receiving one order. A particular customer is purchasing something. So uh, one order has been created. So that particular order information is getting inserted over here in particular table. Then another customer's purchased uh, another order. I mean, he placed one order. Order ID has been created. Maybe the same person again purchase a product. Okay, now think about the thing. I mean, the same customer purchased this another product, but not in the same order. Suppose, I mean, after billing has been completed, we purchase another product. So we created another order. So for the same customer, another order can be inserted over here as a row. Okay. So order ID is nothing but it's a primary key for order table. The particular order should be different. Okay. Over here in customer table, customer ID should be always unique. Okay. But order ID can be repetitive. Why? Just think about this. Maybe this can be the scenario. Two particular customers. This actually this I haven't seen this kind of thing. Maybe just assume two customers is attached with a single order ID. So we are having inserting two different customers over here. Customer 123, customer 234 is attached with one single order ID. Okay, they are the joint owner of the particular order. So their order ID should be repetitive over here. But customer ID should be always unique. Actually, the representation should be, we first declare the primary key maybe in first column. Just like order table, order ID is the primary key. And the same order ID column is mentioned over here. It should be represented as foreign key in customer table. Okay. The same column is primary key in order table. The same column is representing as a foreign key in customer table. You can see about this one. Product table, product ID is the primary key. Product ID is also mentioned over here in order table, which is performing as a foreign key. Okay. Is this clear?
Yeah.
So we are maintaining foreign key and primary key between two tables just for having the relationship. So when we will be learning SQL.
Got it right now.
Yeah, okay. So one more point. So when we will be learning the SQL, we will be learning join. How to join between two tables. Why we will be joining? We will be merging all the data. Suppose few of the rows informations are here, few of the rows informations are here. We will be joining these two to get all the records in a single row. We'll be learning how to join between multiple tables at that time to merge all the information in a single row. If we joined all the tables in a single row, then all of the information should be with us. A particular customer place which order in which date, a particular customer's addresses as well, a particular customer's in a particular order, which particular product has been ordered. All the information should be in a single row when we'll be trying to perform join. But before joining, we must need to confirm whether we have proper primary key foreign key relationship between the tables. If we do not have this common column, suppose order ID is here, order ID is not there. So we cannot have the relationship. We cannot prepare joins between table. Okay, so that is why while storing data in database relational management system, then we must have to put the data such a way that the table should be having sharing common keys so that the data can be shared. Okay, but why we are storing in separate table, that we will be discussing in tomorrow's session. Maybe we can store in a single table, everything in a single table. By checking a single row, let me just show you the thing in an Excel. That should be much more clear. I'm opening an Excel. Okay, the same Excel. Apart from storing the data in different tables, suppose I have a single table. The single table is having information. Suppose, information means the column name, customer ID, then customer date of birth, it's fine, no issue. DOB, then order ID I'm not placing, directly I'm putting the customer. Okay, order ID, let me put it. Order ID. I'm putting which particular product he has purchased in that one. Not putting product ID. The date, customer address, customer's PIN code, the particular product he or she purchased, the price of the product. Okay, I can store all the information in a single table. Then I do not have to join between the table. That can be also possible. If you can think, I'm segregating the data among different tables. Why I'm doing that? I can store all the things in a single table. Then no need to check from other table where is the common column, why we need to join. So there is a reason behind it. I'll be showing this thing in tomorrow's session. It's called normalization. So if we have the big table with having large number of columns, then it's not easy to retrieve data very quickly. And it's not a good way to store the data in the database efficient way. Okay, I just have one thing. It's clear. Okay, fine. So this is for everyone actually. So why we are not storing all the information in a single table? Rather, we are splitting the information based on each of the subject areas. We are storing the columns for each of the table. That things will be covering in detail in tomorrow's session. Okay. The terminology is called data normalization. Okay. So just think about it. We are storing tables with different subject areas, but each of the tables should be having relationship. How we are setting relationships? Because we are having same column present in both of the table. The same column is a primary key in one table. The same column is foreign key in another table. This is the concept. Okay. Moving to the next slide. So when we are storing data in relational database management system, we will be trying to fetch the data. So how to fetch the data? There we need to learn the query language, structured query language. In short form, it's called SQL. Okay, or someone of you can also tell it a SQL, anything you can call. So this is how that programming language will be learning from day after tomorrow. So we should be setting up our relationship database management system. Maybe we can install a particular tool where we can store all those tables and we can perform this kind of languages. The languages is looking like in this way. We'll be learning this thing. This is just a demonstration. put it over here. It's called structured query language. Okay. Okay. Here is a brief introduction on non-relational databases as well. We call this thing as NoSQL. I mean, the languages that we perform over here. NoSQL means not only SQL. N for not, O for only, SQL. I mean, the storage system we already told that it's not a kind of relational database. That means we are not storing the data in table, fields, columns format. We are just storing it, especially as a key value format. Okay, so here is a good example. So we are storing the data. This is a particular rows data. Suppose this is the first name of the employee, John Smith, and we are storing this kind of data. A good things of NoSQL, we can create this kind of hierarchy. Unlike relational database management system, we cannot create columnar level hierarchy. We can create a column address. Underneath, we can create sub columns, street address. It's not possible over there. But it's a possible thing in NoSQL. We can create any kind of hierarchy over here in this way. Okay. So this is the representation of non-relational database. It's called a JSON data. Okay, JSON is one kind of non-relational database management system. Okay, so you can see this is relational database management system, data table, and this is another way of representation of the same data. It's not relational database, but we are representing the same data in this format. It's nothing but the pictorial diagram. It's a line chart of the same data. So this is another kind of data representation. Okay. Starting from tomorrow, example I'm not going to provide. So starting from tomorrow, we'll be mainly focusing on relational database management system. Okay, which is this tabular format. We'll be learning normalization process first. After learning this thing, we will be installing one particular relational database at our systems, and we'll try to create tables. We will be trying to create manipulating the tables. We'll be analyzing the data over there. So this kind of things we'll be learning day by day. But we'll be mainly focusing on relational database management system because I mentioned for data analytics purpose, this is the best database. Data representation, so that we can go ahead the analysis part. It can help us with the analysis part very good way. Okay. Okay, any doubt so far from anyone? So that is the last topic. We'll be going to close the session for today. Next day we'll be learning what is the data normalization process. Okay, I hope it's good for everyone. Thanks for joining the session. Let's connect tomorrow, having the more insights on top of data. Thank you. Bye-bye.
Thank you.
Thanks everyone.